Scenario. The figure represents a door of uniform density that is attached to a hinge at the left and has equally spaced marks along its length. Any one of the five forces can exert on the stick as indicated. Question. Rank which force will create the largest rate of change in the door's angular momentum, from largest to the lowest. Please understand that the torque can be defined as the rate of change of the angular momentum. It is like force. So the answer, we will use the torque equation. The version is with the radius and force. Let each space marker be 1 meter so I can calculate it. The torque of A is going to have the space of 1 meter because it's 1 meter away from the pivot point times that force of 160 newtons. That's going to get you 160 rads per second squared. The next one, I repeat the process, but now it is 2 meters away with a new force of 50 newtons. Multiply, we get 100 rads per second. We repeat for torque C, that's going to be 180. Torque D, which is going to be 160 rads per second, and torque E, which is 150 rads per second. So from the largest to lowest, we have the force C, because force C will produce a torque of 180 rads per second squared because it is 3 meters away. Then second is going to be force of A, which is going to produce 160 rads per second squared, being 1 meter away. That is the same as force D at 4 meters away, also produces the same 160 rads per second squared torque. That's going to be greater than the force of E, which has a torque of 150 rads per second. And the last one is torque of B, produced by the force of B at 100 rads per second, because the force is 50 newtons at 2 meters away. So there you go. That is how you rank it based on the torque equation using the radius times the force.